In 2017, our solar system received its first confirmed interstellar visitor. It was a fleeting guest, detected as it was already on its way out, a tiny point of light moving so fast it was clearly not bound by our sun's gravity. It was given the name Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. The name was poetic, but it would soon prove to be eerily appropriate. As astronomers tracked its rapid departure, the anomalies began to pile up. First, there was its shape. We couldn't see it directly, but by measuring the wild swings in its brightness, scientists inferred it had an extreme aspect ratio, at least 10 times longer than it was wide. The media called it the cigar-shaped asteroid, but it could have also been a flat, pancake-like object. Then came the true mystery, its acceleration. As Oumuamua sped away from the sun, it gently pushed forward, propelled by a force that wasn't gravity. For a comet, this is normal behavior. As ice turns to gas, the resulting jets act like thrusters. But astronomers looked with every tool they had, and Oumuamua showed no signs of a coma, no tail of gas or dust. It was accelerating without any visible propulsion. This single fact ignited a firestorm of debate. While the scientific consensus scrambled for natural explanations, theories ranging from a pure hydrogen iceberg to a nitrogen iceberg fragment chipped from a Pluto-like exoplanet, the head of Harvard's astronomy department, Avi Loeb, proposed a more radical idea. He argued that the simplest explanation for an object with these characteristics was that it was an artifact. A piece of extraterrestrial technology, perhaps a light sail, a type of probe propelled by solar radiation. Oumuamua was, in his view, our first contact with an object made by an alien intelligence. The idea was explosive, and for years, Oumuamua remained a singular, haunting enigma. A one-time cosmic riddle. Until now. For a few years after Oumuamua's departure, the interstellar silence resumed. Then, another object was detected crossing the threshold into our solar system. At first, 3I/Atlas seemed to be everything Oumuamua was not. It was initially classified as just another comet, albeit a very large one on a path that originated from the direction of another star. It had a massive, sprawling coma and a visible tail, the very things Oumuamua lacked. For most, it was an interesting but comfortably natural phenomenon. But for those who had been captivated by the Oumuamua debate, certain characteristics of 3I/Atlas began to raise red flags, creating a creeping sense of cosmic déjà vu. The first was its sheer scale. As we've explored previously, the high-end estimates of its mass were staggering, placing it in the upper echelon of comets ever observed. If Oumuamua was a small, stealthy scout, 3I/Atlas was a colossal mothership. Its interstellar origin confirmed it was our second confirmed guest from another star system, proving that such crossings might be more common than previously thought. Then came its unusual behavior. The comet began to fragment and shatter while still incredibly far from the sun, at a distance where the sun's thermal stress should have been less intense. While comets are known to be fragile, the early and violent disintegration of such a massive body was notable. It was as if it couldn't handle the minimal stresses of entering our system. For a small but vocal group of researchers, the question began to bubble to the surface: what if we were looking at the problem all wrong? What if the differences between Oumuamua and 3I/Atlas weren't evidence against an artificial origin, but were actually evidence for two different types of artifacts, on two different missions? The debate that had quieted down was suddenly, and dramatically, revived. To determine if 3I/Atlas could be a successor to Oumuamua's mystery, we must place them side by side on a cosmic checklist of anomalies. The first and most important box they both tick is their origin. Both are unequivocally interstellar. This is the foundation upon which the entire theory is built. They are messengers from the void between the stars. The next item is acceleration. Here, the comparison becomes complex. Oumuamua's great mystery was its non-gravitational acceleration without a coma. Free-Atlas, by contrast, also exhibits non-gravitational acceleration, but it has a massive, obvious coma. Its movement is influenced by powerful outgassing jets. From a conventional perspective, this is a key difference that proves Atlas is a natural comet. But from a speculative viewpoint, one could ask, is the outgassing proportional to its size and distance, or is it too extreme? Could it be a sign of a malfunctioning propulsion system venting material into space? The most glaring difference is composition and structure. Oumuamua appeared to be a dense, rocky, or metallic object, completely inert. Free-Atlas is a classic, dirty snowball, an active and volatile body of ice and dust. Avi Loeb's theory for Oumuamua was that it was a thin light sail. No one would argue that Free-Atlas is a light sail. But could it be another type of technology? A massive, automated resource-gathering vessel, designed to mine water ice from star systems, whose structure failed upon arrival. Its fragmentation could be seen not as a natural process, but as a catastrophic technological failure. One object, a silent scout. The other, a massive, failing industrial ship. In this narrative, they are not alike because they are not meant to be alike. They are different tools for different jobs. This is the heart of the revived alien probe theory, not that Free-Atlas is Oumuamua, but that they are two data points in a pattern of strange interstellar traffic. Science, however, operates on a powerful principle known as Occam's razor, which states that the simplest explanation is usually the correct one. Before we can entertain the extraordinary hypothesis of a failed alien mining ship, we must first rigorously rule out all ordinary, natural explanations for Free-Atlas's behavior. And when we apply this principle, the case for a natural origin becomes incredibly strong. Let's systematically address its anomalies. First, its interstellar origin. While once thought to be exceptionally rare, our detection capabilities have improved exponentially. Projects like the Pan-STARRS telescope, which found both objects, are scanning the sky with unprecedented depth and speed. Finding more interstellar objects is not an anomaly, it is the expected result of better technology. Second, its immense size. While Free-Atlas is large, it is not impossibly so. Our own Oort cloud, a vast reservoir of comets at the edge of our solar system, is believed to contain trillions of objects, some of which could be as large or larger than Free-Atlas. It is statistically inevitable that other star systems have similar Oort clouds, and that occasionally, a gravitational nudge will send one of their largest inhabitants on a journey our way. We simply witnessed a rare, but entirely possible, event. Finally, its fragmentation and trajectory. The idea of thermal stress causing it to break apart is well understood. The temperature difference between the deep freeze of interstellar space and the gentle warming of our outer solar system is extreme, and for a body made of volatile ices and dust, this can easily create internal pressures that cause it to crack and shatter. The subsequent acceleration and chaotic path are perfectly explained by asymmetrical outgassing, where these jets of vaporizing ice act as uneven, natural rocket engines. Every single observed characteristic of Free-Atlas has a plausible, well-documented, and natural explanation. So, where does this leave us? The direct comparison shows that Free-Atlas and Oumuamua have more differences than similarities. The application of Occam's razor strongly suggests that Free-Atlas is a spectacular, but entirely natural, interstellar comet. And yet, the debate itself remains profoundly valuable. The existence of these objects, and the provocative theories championed by scientists like Avi Loeb, serve a crucial purpose. They force science to confront its own assumptions and to push the boundaries of what we consider possible. Without this pressure, without these what-if questions, we risk becoming complacent, ignoring data that doesn't fit our existing models. This debate leads us to a fascinating third possibility, a middle ground between a simple comet and an alien probe. Perhaps these interstellar visitors are not one or the other, but represent an entirely new class of celestial object we are just beginning to understand. The environment of interstellar space is different from the cozy confines of our solar system. Objects adrift for millions of years, bombarded by cosmic rays and bathed in the light of distant stars, may evolve in ways we haven't yet imagined. Oumuamua's lack of a coma and free I/Atlas's fragile structure might be the defining characteristics of these interstellar travelers. Perhaps we are not finding alien artifacts, but we are discovering a new chapter in the cosmic playbook. Ultimately, the true value of these messengers is not in the answers they provide, but in the questions they inspire. They are a test for our science, a challenge to our imagination, and a humbling reminder that just when we think we have a map of the universe, it reveals a whole new continent to explore.